Today we're going to discuss how to factorise a quadratic of the form ax squared plus bx plus c. We should all know that factorising is effectively the opposite of expanding. When most people are taught how to expand, they're taught to use the FOIL method, first, outer, inner, last, which is a brilliant little trick, but that's what it is, it's a trick. To be able to factorise properly, you have to understand how to expand properly. So I'm going to look at that first. Now imagine we've got this quadratic here. Now, if we used FOIL, we'd get the right answer. But what we should be looking at is, the first thing we need to do is the first term in the first bracket times the second bracket, which will give us this. Once we've done that, we need to look at the second term in the first bracket times the second bracket, which will give us this. If we expand, we'll get to this. Now, this is what FOIL will give you. So FOIL effectively misses out one step, which is incredibly important when you're factorising it. So now we're back at the 6x squared minus 15x plus 2x minus 5, and we just collect the like terms to give us 6x squared minus 13x minus 5. So if we look at how we are going to factorise one of these, so I've got one here. So I'm going to factorise 6x squared plus 11x plus 3. Now when we expanded, the last step we did was we collected our like terms. So the first step we're going to do when we're factorising it is we're going to split them. Now to do that we use something called the AC method. So in our quadratic, A is 6 and C is 3. So AC, A times C, is going to give us 18. So if we look at the factor pairs of 18, there's a load of them. So we've got a few here. 1 and 18, 2 and 9, 3 and 6 would all give me 18. Now out of those three, the only one that will give me the 11x in the middle when I sum them is the 2 and 9. So I can now rewrite my original quadratic as 6x squared plus 9x plus 2x plus 3, which is exactly the same as what we started with, just split. Now, when we did the step I've just highlighted, we expanded each half, so we're also going to do the opposite. We're going to factorise each half. So if I look at the first half of this only, 6x squared and 9x have a common factor of 3x, so I can factorise it into 3x times 2x plus 3. My second half, the 2x and the 3, have a common factor of 1. So if I factorise that out, I get 1 times 2x plus 3. When we expanded our first step, we noticed that one of our brackets gives us the two brackets. So in our factorisation, the 2x plus 3 is in both brackets. It should be the same, it has to be the same. If it's not the same, you've made a mistake. 2x plus 3 is going to give us our first bracket, and the other one is going to be given by the 3x and the 1, which will give me 3x plus 1. Now if I expanded that to check, I would get back to 6x squared plus 11x plus 3. What we're going to do now is we're going to discuss a few cases that cause problems for people. So the first one, 6x squared plus 10x minus 4. And if I follow through the same process, I do my 6 times my minus 4, which will give me minus 24. Now that is important that it's minus 24, because I know that one of my values on the split therefore would have to be negative. So if I look, factor pairs of minus 24, which is sum to positive 10. So I've got 1 and minus 24, 2 and minus 12, 12 and minus 2. The common mistake people will make here is they'd use 2 and minus 12, but that will give me a sum of minus 10. So I've got to use the 12 and the minus 2. So I split again. I've got 6x squared plus 12x minus 2x minus 4. It's worth noting that they do have to have the correct signs. So the plus has to be with the 12 and the minus has to be with the 2x. However, it could read 6x squared minus 2x plus 12x minus 4. It doesn't make a difference. So, again, factorising the halves gives me 6x times x plus 2, and the second one, I've got minus 2 and minus 4, so to keep my two brackets the same, I must have a factor of minus 2. Putting them together gives me 6x minus 2 and x plus 2. The next one is like this. We've got 8x squared minus 10x plus 3. So, using my AC method, I've got 8 times 3 is 24. However, when I'm looking for factor pairs, they must multiply to 24, but sum to minus 10, which tells me they both must be negative. Here's a few. The one I'm going to be looking for, minus 2 and minus 12, look like they could give you 10, but it would give you minus 14 on the sum, so the one I've got to use is a minus 6 minus 4. Splitting it up, 8x squared minus 4x minus 6x plus 3. Factorising by halves gives me 4x times 2x minus 1 minus 3 times 2x minus 1, which will give me a final solution of 4x minus 3, 2x minus 1. The last of our special cases is this. Every time I've taught this, kids have got themselves all sorts of confused, because if you're doing 4 times minus 96, it's a huge number. You don't want to be dealing with it. Ones like this, a lot of the time you can look at them and you'll notice that it's got a common factor. So what I can do here is factorise out the 4, which will give me this. 4 times x squared plus 2x minus 24. That quadratic can then just be factorised. Sometimes you might get something along the lines of 2x squared at the start. In that case you'd have to use the AC, but this, we can just factorise it. We're looking for two numbers that multiply to 24 and sum to 2, which is going to be plus 6 and minus 4, which gives me this. 4 times x plus 6, x minus 4. Now if you had tried to factorise it using the AC method, you'd have got something along the lines of this. Now they are exactly the same thing, but the second one isn't fully factorised. That first bracket has a common factor of 4. Most of the time this won't be a problem. However, if the question says fully factorise, you would lose a mark. We're going to look quickly at a contextual question. So we've got a question here, a rectangle is shown, find an expression for the perimeter. If it's a rectangle, we know that the area is going to be one side times the other, sides are going to be equal. If we look at the area of this, we can say that it is going to be expressed by 12x squared plus 11x plus 2, and if we factorise that, we would get 4x plus 1, 3x plus 2. This tells me that one of my sides is 4x plus 1, and one of my sides is 3x plus 2. If I'm finding the perimeter, all I do is add all the sides together, and then I would get 14x plus 6.